Hello, today I'm going to be going over Lab 2, Charge Tape. The purpose of this lab was to model the electric field and force of repulsion between two charge tapes of the same charge. As opposed to last lab, where we modeled this as 2 point charges, and this time we will be modeling it as two lines of point charges. And the result of this was that the charge of the tape required for this new model is much greater than the charge calculated by the old model. So let's go over the models and fundamentals. So the model consists of two lines of a variable number of point charges, and the electric force and electric field are based on Coulomb's law, where the field equals K Q over R squared, and the force equals K Q1 times Q2 over R squared. And we also are using the force of gravity, as the force between the charged tapes has to equal out and cancel the force of gravity. And here we have Mr. Gravity at the bottom of the slide. Now, assumptions in the model. We are modeling the tapes as a line of 1D charges and not a 2D sheet of charges. And we also assume that the charges are uniform and equal along and between the tapes. So there's no different charges between the tapes. Now, what's a system and surroundings? The system is the top tape. The surroundings are the bottom tape and the earth, which is acting on it. So here we have the first part of the code, where we set up the physical constants, the mass of our tape, and the estimated charge on one tape. We also have the equation for calculating the electric field, given a charged particle and an observation location. At this part of the code, we have a function for creating the lines of charges based on the n, which is the input number, which is the number of point charges in each line. So we create spheres of point charges, and these will be used in the next part. So it iterates through each point charge on the bottom tape and each point charge on the top tape and creates an electric field at each point charge on the top tape and electric force overall on the top tape. Now we just need to create the arrows to represent this in our model, which is what the following section of code does. And as you can see, we create the vector to represent gravity. So here are the results. The charge needed was roughly 1.52 times 10 to the negative 8th coulombs, while the charge calculated from last time was 4.67 times 10 to the negative 9th coulombs. And our magnitude of electric force, gravitational force are equal, roughly. The sources of error are that the tape is not a line of charges, but a sheet of charges, so our model isn't quite accurate. Also, the tapes aren't necessarily equal in charge, and the charges aren't necessarily uniformly distributed. And the lengths of the tape were estimated, as well as the distance between the tape when gravity was canceled out. So what if, as previously stated, the previous model, less charge was needed than in this model to make the top tape float? So our conclusion is that if you want to take this lab further, the charge would be modeled as rectangular sheets, not as lines.